I've just filmed an example where, using StatCrunch, we showed how the linear regression equation line has a lower sum of residuals squared compared to a line that went through the first and last points. I used StatCrunch to show that. I believe this next example is of the same type. I'm going to show how to use the TI-84 instead, if I'm remembering what type of example this is. So first off, let's find the scatter plot or scatter diagram that best fits the data shown here. Since this is going from 0 to 100 along the x-axis in choice A, we've got 10 spaces, I believe. 1, 2, 3. Yes. That would mean we should see the first point, 20, 80. The x-coordinate would be here, and the y-coordinate wouldn't even show up. We couldn't show the point in the y direction. So it's down to choices B and C. For some reason, the x-axis in choice C starts at 10. 1, 2, 3, 4, 5, 6, and then the first spot. So 7 spaces divide up. From 10 to 70, going by tens. 20, 30, 40, 50, 60, 70. That looks to work. Whereas we're going by tens from 0 to 100 in the y direction. This does look like 20, 80, 30, 75, 40, 70, 50, 64, and 60, 50. It looks like choice C is the one. It is. So let's see what is asked next. Find the equation connecting the points 30, 75 and 60, 50. So the second point and the fifth point. They want this to be written in slope-intercept form. Regardless of how you start, you need the slope. Now, in the other example where I used StatCrunch, once I had the slope, I solved for B by starting out in the slope-intercept form, filled in the slope, and used one of the points. This time I'm going to start a little differently. I still need to find the slope first. So y2 minus y1 all over x2 minus x1. Which one you call the first and second point doesn't matter. I'll call this the second point. The y-coordinate is 50. So subtract from that the first y-coordinate, 75. And since I started with 50, then the x-coordinate I have to start with is 60. Subtract from that the other x-coordinate, 30. So that's going to be negative 25 over 30, which we can divide by 5, top and bottom, to get negative 5, 6. I could start with a point slope form. Fill in that slope of negative 5, 6, and then pick either points. As long as you do your work correctly, pick either points, and you should be able to solve for this to get y equals mx plus b4. So I'll go with this one, 60 for x and 50 for y. Distribute the negative 5, 6. 6 goes into 60 10 times. So I'm multiplying a negative times a negative. That'll give me a positive. 6 into 60 10 times. I still have to multiply by the 5. I've already worked out what the sign is. And then adding 50 to both sides, our equation would be negative 5, 6 x plus 100. So let's plug that in and see if my lab agrees with that. Here we go. Type integers or simplified fractions. Okay, they already have the x there. And here's our y coordinate of the y-intercept. and it's good. So we picked choice C back here. I'm hoping that this is going to look similar in terms of the labeling of the axes from 10 to 70 in the X direction and 0 to 100 in the Y direction, of which only A and C have that, but we have a negative slope. It looks like we have a horizontal line showing in A, whereas in choice C, we have a line with a negative slope, and it's going through the second and fifth point. Now we want to come up with the equation of the least squares regression line. So I am going to do that by using the TI-84 this time. Got to clear out some previous data. Then my x's of 20, 30, 40. Make sure that things are read and typed correctly. And then we've got 50 and 60. In the Y direction, keeping things paired up the way they were expressed in the table. To get our least squares regression equation, press that again, go to Calc, and we choose linreg, parentheses AX plus B, tell it things were in list 1 and list 2, or wherever you stored them. Plus, I'm going to store the regression equation. Second, sorry, I don't need second. Just vars, y vars, function, and y1. If I have anything in the y equals menu, it's going to wipe out whatever was in y1 and replace it with the equation of the regression line. And when we calculate, it's giving us a slope of negative 0.71. It does not even go 3 places, so I don't need to do any rounding. And a y-coordinate of y-intercept of 96.2. So notice that negative 5.6 is negative 0.83 repeating. Let's see, what was that? This is a little far away from that, but yeah, negative 0.71. We're kind of close to the decimal approximation of negative 5.6. Then the 96.2 for the y-coordinate of the y-intercept is kind of close to the 100. Now we want to see the scatter plot along with the graph of the regression equations line. It's stored those. So zoom N9 will show both the scatter plot and the regression equation line. We're seeing the first point is a little bit below it, the second maybe on it, the next two a little bit above, and the fifth a little bit below. So either A or C. I'm going to go with C again because of the similarity in the labeling of the x-axis from 10 to 70 and in the y direction from 0 to 100. Scatter plot looks pretty similar to what I see up here. And what I was saying about some points above, some points below. Let's see if I remember that correctly. It's like we're good. Okay. So using the line in part B, which was the negative 5.6x plus 100 equaling y. What I'm going to do here is as follows. I'm going to set up a new column based on the following. A residual is a predicted value. Sorry, it's about to say that in the opposite direction. Observed value, for example, that first point, the observed value is 80 minus the predicted value. So I'm going to take 80 minus the predicted value would be negative 5.6. Let me get the negative sign here. Let me just show the whole calculator for this. So it was negative 5.6x plus 100 was equal to all of y. Negative 5.6. Parentheses around that. Times what we have in the x coordinate, L1. So we've got the observed value of 80 minus 5.6x plus the 100. It's going to give us the residual, but we want to find the sum of the squares of the residuals. Okay. So I wanted to do that not just there, but for the entire table. Let's see here. That and edit. Okay, so I'm going to go to the top of L3 and type out what I did before. Tell it what's in L2, the observed y value, minus parentheses, and then another parentheses because that slope was a negative 5.6, times the x coordinate, which was in list 1, plus 100. 100. Okay, let's see. One, two, three. Yep. Okay. So that would be observed minus predicted. That would be the residual. Get the square of that. It's filled everything in. And we want the sum of the squares. We've got the squared part. So we want the sum of what's in list 3. We can get that from stat calc and one variable statistics on what is in list 3. There we go. That's 54.3 repeating. And let's see how they want that typed. So let's go back to my lab. 54.3 repeating, and they are letting us round to 3 places. That would round down. Okay. Do the same for the equation we got for the least squares regression line. And that can actually do something similar, but perhaps a little bit easier. So here we go. Clear out what was in list 3 from the old line. The regression equation is supposed to give us a line that fits better, that we will have a lower square, a lower sum for the squares of the residuals. So clear that out. And now, remember, I had stored that equation in Y1. So what I need is for what's in list 3 to equal, I'm going to square this at the end, so I'm putting parentheses around it, the observed y value in list 2 minus the predicted y value for the same value of x. That would be, think about how we stored y1, stored the equation of the regression line. vars, y vars, function, y1, and then we tell it that the x coordinate is in list 1. Close that parenthesis, close the overall parentheses, and square it. And now go back to the sum of list 3 in stat, calc, one variable statistics. I put that in list 3 also. And we're getting a sum that we see on that second row, 32.7, which should be less than what we put in previously. Back to MyLab again. If I've done my work right, that is less than 54.3 repeating. Let me double check what I had there. That was 32.7. And you're not seeing MyLab right now anyway, so here we go. 32.7. One more double check before I hit enter. Yep. Okay, there's that. And so the line in part B went through more points, but thinking about the overall set of data, what we have in part D has minimized the sum of the squared residuals. Therefore, that is a better fitting line.